Okay, hello. So this is the video presentation for my project 3 semi-structured data analytics. We have given 5 questions that we have to analyze, and let's begin. So the data is actually from MongoDB. It's from the database called sample supplies, and from the data is actually for sales. So the source, the way I import is actually in a JSON file in a JSON data manner, which is here project3.json. And I'll be transferring it to a CSV before analyzing it. So since the beginning, I've imported CSV and also Panda, of course, to analyze it. And here I have read the JSON file. Here's the example, the data that we have. So we have around 5,000 rows and 7 columns. This is data info. All of our 7 columns are the name of our columns. And I have also defined a data CSV because I'll be transferring the data into a CSV to a CSV. And also I have defined 11 field names in a CSV. This is just I'm printing the row to check. And before transferring it, I would be flattening the data because it makes it easy. It makes making the query easy, and also it's it is compatible with the tabular, showing the data in a tabular form. And this is just me indexing it with each column. And after that, I would be writing it in a CSV file. And also, after it transferred to a CSV file, I'll just print it so that we can see we have around 27,000 rows and 11 columns now. These are just the name of each column. So let's begin with our first task, which is we have to show the top 10 products by their sales. So for that, I have defined the product sales, and also we have to calculate this quantity into price. And I have done that, and I have also assigned it to a different name, sales by product, which I have also grouped it. I have grouped it by its item name and item sales. So, and also have made it. I have imported matplot library so that I can show it as a graph, plot it as a graph. So the result is here, and as you can see that the sale for laptop is the highest, and literally leading the pack, while rest of the products are there, but rest of the products are very similar to each other, which their sale is quite near to each other, but laptop is the highest. Here you can see in a graph format, it almost touches 7 million, but it's just 6.7, I think 6.7 million dollars of sale. While others, backpack, pens, and everything, they have lesser than laptops. And also like blinded notepad, envelopes, and everything. But this is mainly due to because, as we can guess, is mainly because laptop prices are higher than rest of the products. If you're comparing backpack, pens, and laptop is like quite expensive. So that's why like each of its sales has a very high, like it has a very high sales because it's expensive. For question 2, we have to show top 10 products sales by store location. So again, we have defined it. We have defined the product sales, but for this we have to multiply. I have to multiply. Oh, no, not multiply. So I'm graphing this according to the sales location, and also yes, we have to get the multiply. We have to get the product sales, which is item price and item quantity, as suggested in the first one. And I'm also like sorting the sales in a descending order and selecting the top 3 products by sales for each location. And we have gotten the result in a table format. And this is for each store location: Austin, Denver, London, New York, San Diego. And around here, you can see Seattle having the highest product sale, which is for laptop, coming in with, and then Austin. So here's the tabular form. Denver, actually, in this graph, we can see it more clearly. Denver, for laptop, Denver is the highest, and coming up next is Seattle. While again, this laptop leading the pack with like a very high margin, it's mainly because of its quantity. Its price is very high. Like it's not depends on its quality, it depends on its price, which is laptop is quite expensive. So Here you can see like Denver location has like the highest for each product, the top 3 product, which is laptop, backpack, and pens. So and this is also like the data displays the combined sales for the top 3 items at each store location. In particular, the laptop category standouts, as I've explained earlier. And for question 3, which is show ranking of each store location. Again, I have ranking of each store location. I just received this, so I just made it according to the sales. So of course we're calculating the sales again and grouping it by location, store location, and calculate the total sales of each location. And we're ranking it according based on the total sales. For this, I have also created a data frame, which is store location, total sales, and also the rank. And I'm also displaying the data again in a visualized bar graph format. So here you can see the entire sales for each store location is shown in this bar chart, which provides the valuable insight. And also with Denver having the highest overall sales, reaching almost like $2.92 million. And it's like the best performing retailer, and followed by Seattle and then London. This is this one is in Europe, and rest of it is in USA, and I think this one is from Argentina. For question 4, show purchased method by gender table. We have been provided in this format, so I'll be doing it in this format. Yes, for this I have to like filter the data for specified purchase methods, which is on store in store and also online. And we are data pre-processing it by filling the missing values with 0, and also reordering the columns to match the desired order, so that like it actually shows at the actual place. And we are like displaying the purchase method by in a gerund table, and also I'm also plotting it in a bar graph as for every question. So here you can see actually the in-store way of purchasing is more used for both of the genders, including male and female. But the online way is actually, for the online way, males consider doing online more, but it's a very slight difference, only like less than less than 100, it's like around 44. And but if we're seeing it in a big perspective, female actually lead lead the way of purchasing, especially in an in-store one, where they do like around 8,062, while male just do around 7,571. So in this we can see like female contributes the most in buying. I mean, especially in an in-store, but male, they prefer, just the data that we have, male prefer more online, even though having less purchasing unit than female. For question 5, we'll be showing the monthly total sales. So from showing the monthly total sales, we'll be converting the sale date to date time and date time format, so that we can extract the month and year. Otherwise, we cannot. And also, we'll be grouping them by year and month, and resetting the index for tabulating, and select only like necessary columns, which is in month, which is date time, and also item price, and also date time and sales. And yes, for this one, we'll be showing the data in a tabular form here. Also, for this one, we'll be doing the graph in a line plot manner. And let's just go to the result. This is like the graph. This is like in the tabular form that is provided, but it's not quite clear. So that's why you have to like hear more. And with this, actually, you cannot sense the pattern throughout this, but as you can see, like for each year, you have like 12 dots indicating 12 months, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So like this month, January, February, the 12 months in a year. So as you can see, like for each for each year, the first month has the highest sales. For 2013, 2015, and 2016. Okay, I quite take back, but I mean, yeah, the highest sales that we have is actually for 2015 January. Actually, I cannot quite make much sense of this because it's very random. Like, but as you can see, you can also like think that for third month for March, in some year it is like a boost after a drop down. For example, like in 2014, January, February, March, and also in 2016, January, February, March is that coming back to the normalcy what we have. But and for each year, January is quite from around like days. It's a very it's very random. So like for this 2015, you can see January having the peak, but here in 2014 is dropping down. Same with like 2016, it's going down, but in the February of 2016 is very quite very decreasing. Same with 2017, February has a very less like it just goes down steep the hill. But same with 2013, but in 2014, you can see it's coming back a bit after. So it's very quite random. But as you can see, as from the theory, after every new year, maybe like after holiday Christmas, like after New Year, after December, around January, you can see like most part of it, it is decreasing. Only like two out of 5 is increasing a bit, but then also after increasing a bit, it's going back low. So we can like have an idea that after New Year or like Christmas, the sales go down, but it also climbs back up after the third month. Around fourth month, it climbs back up. But as you can see, the peak that they have is for January 2015, and the lowest that they have is for February 2016. So that's it for the project.